Hello, folks. Uh, this is Mohit. Actually, today, while going through some concepts of Scala, I was looking into some basic concept of Scala, that is uh, tail recursive functions. So, as you are if you know Scala a little bit, then you must be knowing that in Scala we need to focus on how to do things in a functional way. Instead of doing the imperative style of coding, we need to make everything in functional. So that's why Scala more focuses on to reduce the usage of while loop, because it's keep on changing the variable. We need to use where kind of things in while loop, so we need to change the variables. So Scala itself uh, tells us that don't try to use that, because that's not the functional kind of programming. That's more of a imperative style. So in that case, to reduce this while loop usage, Scala has a good optimization in the form of tail recursion. So let me show you what exactly the tail recursion is. Tail recursive functions. Tail recursive functions are the functions which call itself at the end of the logic, at the end of the body. Means the simple thing is, it the function needs to call itself after the end of the body of your function. It should not contain anything else. Mind my words, it should not contain anything else. So let me give you one such example. Let's suppose we have a function called uh, my function, my function, for which I am taking the input as value, which is of integer type, and it is returning the integer as well. So what I am doing is, I will create. I'll check. I'll first of all check whether my value, that is value is 0. Then then we need to return some value of 0, and else 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 we need to call the my function, uh, my function value dot value minus 1. So sorry. So this is the proper example of how a tail recursive function looks like. In this, Scala itself does a kind of optimization while going through the tail recursive functions. Whenever the Scala compiler finds a tail recursive function, it automatically creates logic that contains go-to statements in it. Means after every iteration, it will change the value and will instead of going through the function again, it will internally uh, makes a go to command, which will simplify the process. So this is the optimization process which Scala does. And there are few main things that you need to remember. First thing is, um, the function should always be tail recursive. Tail recursive means itself it should call itself at the end of the body. Here you can see I am calling that function itself, nothing else. Not an addition, not a subtraction, nothing else. Calling the function with the new value. That's it. If suppose we have something like yeah, we have something like similar to this. We have something like plus 1. So this is you can see this is not a tail recursive function, because every time it's need to return some value. So it's not a tail recursive function, and for this it will not give you the optimization. I'll show you with the proper example. And the other thing is, while working on a Scala, I think you should you always use that part. What was it? Well, some function, when we use the function literals. Well, some functions. Then let's see, my function, and that's it. Okay, if suppose you are using this thing and you are calling this function my function, and inside that function you are using that func. So if you are thinking that in this case also it will gonna work, then no, a big no, because this is a function value. So every time when you calls it, it gives a value, it assigns a value to it and provides the my function with that value. So it applies value to the function. So internally it will not fall into the criteria for which it will do the optimization. As we can see, it is doing when the function is tail recursive. So this is also not the case of tail recursive functions. And other thing that I want to show is the example. Yeah, so I have prepared some example. uh, I have prepared some example. So here you can see I have created the same function that I was talking about. Try me. That's something recursive function, and I am calling it from here, this main function, and I am using the object that is try recursion. So let's run it. So you can see it is taking around 50 milliseconds, 40 milliseconds. It is taking around this much. But when you try to do something like this, no. So first of all, let me show you with some small digits. So let's suppose 1. So it will take around 40 to 50 seconds, milliseconds. That's it. It will vary. It will vary. And if suppose you want to change something, so I was talking about this is not a tail recursive function, so you were thinking that it will not work. For this small value it will work, because this is not uh, the proper use of recursion. So here you can see it is giving the 10 value because we are doing the addition. So it is giving the 10 value and time is similar to that. But when you will increase this value, let's suppose I have increased to this much, it will gonna be creating some trouble. You can see here we are getting this stack overflow error, because in this, for every iteration it is storing some value, and to store that value we need some memory. So for every iteration, suppose this is the iteration, so to store the state of the object, we need some memory, and that memory is you can say is more than the heap size of it, more than the JVM provided to this program. So this is the thing. And if suppose we do something like this, so it is running as usual, 39 seconds fast. And the other thing that I was talking about was, let me show you. I suppose I run fun. In this case also it will work, because it is again the recursive function only, so it will not causing any problem. But if I put fun over here, it will give me stack overflow error, because again this function is a kind of function value, is an instance of a class. it's an instance of this function which is uh, which it's a function, it's a value of this function which is itself an instance of some class which extends a trait, that is function 0, function 1. You will get to know when you go through Scala programming guide and all. So this is capturing some value and we need to store that to memory. So we again need some memory, and that too for this much of iterations. So it's quite big. So again we are getting the Stack Overflow error. So guys, whenever you are trying to use tail recursive functions, then make sure that you are not doing anything like making some complex things and doing some addition at the end of calling the function. Don't do such kind of, because it is not the proper Scala usage. And one thing more, uh, if you go through this example, if you go through this um, PDF, you can see that for these kind of situation also, where your recursion depends on another function. Let's see, is even is calling is odd, and is odd is calling is even. So here the compiler gets confused. So so it will not optimize your code. It will again show you some error, and whatever it will be Stack Overflow error or something. So it will give you that. So don't do such things when you are going for tail recursive functions, and try to utilize this tail recursion instead of doing the while usage in your code. That's it, I guess. This is all about the tail recursive functions. And thank you so much, guys. Thank you so much. Happy coding. Bye.